Today we have Dee Cristicelli. She is the director here at KCM and one of our beautiful thought partners. You're in for a treat. I look forward to learning from you, Dee.
Thanks. Gonna hit presentation mode. There we go. All right. Hi, everyone. Welcome to Thursday's edition of Geometry for the Week. We're going to do some more conceptual understanding work. Today, we're going to focus on 7th and 8th grade. This is me. I am at your disposal if you have questions or need anything. Please feel free to contact me there. For a good chunk of this week, we talked about the Hiele Levels of Geometric Thinking, and I want to spend just a minute talking about where we are in this trajectory. We are looking at 7th and 8th grade students and standards. So I've put a big arrow there for sort of where we are in this. We talked about the visualization stage, just dealing with this as a shape and it's a triangle because it looks like a triangle, and then classifying them based on some characteristics, leaning into analysis, and then talking about the properties of shapes, that they are this particular shape. They give this name because they have these properties, and that's where we're leaning into in 7th and 8th grade. We want students to own these properties, but then they're starting to think about the relationships among the properties, and we start to lean into informal deduction. So we want to know, for example, if a quadrilateral has 4 right angles, it also has diagonals of the same length. And it's not a thing we're memorizing, it's a thing that we understand. If these things are true, then these other things must also be true. And thinking about that informally, not in terms of real geometric proof just yet. So in 7th and 8th grade, geometry is a big deal. And I think for a long time, we've sort of neglected it to our peril, actually. Algebra and geometry teachers for high school will nod and go, yes, yes, yes. In these 5 big clusters in our geometry standards, there are 14 standards. And I want to let that sink in for just a minute, because 14 standards, right? That is not a 2-week unit. And I see far too many schools doing some making everything into a quick unit, right? And you just can't do that. You just can't do it. Sorry about that. I don't know what happened. So we're going to start with an activity that's in the packet called Can You Build It? And it's a series of just listing out, can you build these particular shapes, right? And then there is a geo board. Can you guys see my geo board dot paper?
Yes, we can.
Okay.
Nice and clear.
Awesome. So in GeoGebra, which is a handy dandy awesome tool, there is just square dot paper designed that you can loop things on and do things with to serve as geoboard paper, basically. So you could assign this to students and have them try to draw, right, whatever it is you've asked them to do. So you can take it and click and do another segment. And so I want a shape with a right corner, but only 1 right corner and 4 sides. So I can do that. Oops, I lost my D. D. There we go. And so you can have the students build that. You can have them screenshot and share. You can have them share with each other. There's some other tools that students can play with. But in the GeoGebra, you can have them do that just to build out the different shapes to see if they can indeed build those different shapes. I specifically included in here something about a non-example. So tell me about D in this can you build it sequence. Is D something that we can build?
Nope.
It is not, right? Tell me what does not work about that one.
A triangle with 3 congruent sides would need to have 3 congruent acute angles. So they would all be 60 degrees.
And so can I have an obtuse angle is 60 degrees obtuse?
Oh,
No. But having kids actually try to figure that out, to build something, have them see what it means to have 3 congruent sides. Well, what does that mean? As they try to build it out, that actually has that make some more meaning for them, right? I've seen these charts where here are all these different kinds of triangles and we need to memorize which kind. No, this is not a memorization thing. This is a feel it, do it, right? Feel out and see what's happening with these sorts of things. And so use these kinds of tools to give students that opportunity. The standard as it's written for us in Kentucky has them being asked to draw them, to physically draw them, and with technology, right? So use these things that we have available to us to do that sort of work, to have them build it, see what is possible, make connections between, if I have to have 3 congruent sides, I have to end up with angles that are the same, which means then, therefore, right, I cannot have an obtuse angle. That's where we start to make those connections between the specific properties and then the relationships between those properties. The standard specifically here is to draw freehand with ruler and protractor and with technology, right? Shapes with given conditions. So you give them conditions, you give them constraints and see what they can do with it. They also want to focus on triangles specifically, right? And sort of notice when they determine a specific kind of triangle, and we care about those types, but also that sometimes no triangle is possible. And so giving them opportunities where they see examples of different types, but also non-examples is really important. In your packet, I gave you an article. We've all referenced the Van Hiele levels. So this is an article that was written by him in 1999. I say that not to say, oh, it's an old article and maybe it's not any good anymore. I say that to say he's been laying out the case for doing geometry a specific way for a really long time. And it's another one of those things where I don't know why we're still trying to do things that we know don't work. Why don't we try the things that we've been talking about and researching for a really long time? But he has this article. It was originally written thinking about intermediate moving into middle school. And so a couple of the things really are meant for intermediate students, but I would posit that our middle school students actually haven't done all of this work necessarily, and we've realigned the standards since he wrote this. And so I think all of this has some really, really good, worthy value. So I would encourage you to read through that article. But one of the things that came from his work with students was this idea of play as really the precursor and maybe the most important part of learning geometry. That kids need to feel it and touch it and actually manipulate it. And so in your packet, you have this activity called Mosaics, which has been adapted from that article. And it's got a common, a free share license at the bottom. So please feel free to use that, adapt a little bit as you need it to for your classes in terms of that. But it has this 7-piece mosaic puzzle that kids do all sorts of things with. And it starts off relatively simple, which is why it looks like an intermediate activity. But I would really posit that once you start to cut the pieces apart and having to manipulate them, most of our students haven't done a lot of this work or haven't done enough of it unless we're doing it with them. And so we really need to give them opportunities to manipulate those pieces to see what happens when they shift them over, when they slide them over. What pieces can I put together to make something. And so one of the tasks is to decide what kind of pieces can you put together to build a parallelogram. And there's more than one way to do it. And so you'll have kids find one way really quickly. And so is it possible to do it with 2 pieces? Is it possible to do it with 3 pieces? And actually have them go through and do that because they need the experience actually physically moving and flipping the pieces to see what is possible. And then it also has them run through some other activities and then make their own puzzles. And that's one of the things I like about this one is having them make their own puzzles, put together the puzzle pieces the way they want, trace around it, make a puzzle to share with other people. And then you start getting different ideas because you can make all sorts of really interesting things. And kids can get really creative with this if we just give them a few minutes to do it. But there's something about physically handling the pieces that goes a really long way in understanding things. Some of what happens when you're doing this with kids is they'll talk about how they had to slide a piece over or flip it over, and you can start leaning into, for middle grades, that just-in-time vocabulary that goes with that for some of the different translations that we're going to talk about in a little while. Any questions? So this leans a little bit into the area of two-dimensional objects because we're playing with those shapes and seeing how they fit together and go together. And so while it is one particular standard, it also starts to lean into this next one. That is the thing about geometry. So much of it is interrelated. I'm glad it wasn't my job to divide them out into distinct standards because so much of it is interrelated. Because manipulating the shapes helps students see the composite area. Composite area of oddly, shaped figures is built of composite area of more simple shapes. And that actually manipulating that around and doing lots of this puzzle work helps them see that area is a composite thing, not just composite, in the sense of we did tiling work to think about it with rectangles. You can actually do that then with multiple shapes. And then it also prepares them for some stuff that's coming next, which is shapes start moving and changing in all sorts of different ways. And so something I'm going to try to put in the chat. For you, you got a couple ways to do there. If you go into Desmos, student.desmos.com, you can do that, or that link will take you to our Desmos activity we're going to do. I'm going to give you a few minutes to get in there. And there's no partnering up for this one. So just come on in and we're going to start working through an activity together. Yay, I see 6 of you are in.
It says activity paused for me, Dee.
It is, oh, I will unpause. There you go.
Now it's working. Awesome.
Thank you. I paused to make sure that you guys were getting in before. So just follow the directions on the screen, please. I have now reshared my screen. You guys keep working through. Some of you are working through fast. I love it. Couple more minutes. Okay, everyone, I'm going to pause. So you're not going to be able to play for a little bit. And then I'll reopen it up while we work on some other things because some of you won't be able to stop. And that's okay. I understand. But I want to pull us back to look at what is on the screen at the moment because I want you guys to see what I see. Okay. So from a teacher perspective, I can see all the different things that you guys have done, right? And I can choose to pull out some of those examples if I want to pull those out in a whole group discussion, whether that's in person or virtually, and walk through some of the different things that we've done, okay? Which is just so, so fun to do. One of the things I want to do right now is I'm going to go over here and walk through the screens. And so we'll look through, so the warm up, this is what sort of it did. You can see what students said and did, right? So what did you think about this? Some of you get on and talk to me. Oh, look at some of your kaleidoscopes. I love it. I love it. So here's where I want you to talk to me. Lots of you want to get back to the kaleidoscope. Isn't that great? Isn't that great? And it's fun to have people start talking about like, what did the kaleidoscope do to your figure, right? What are things this would be good for with students?
I love that it opens up, you start with informal language, just what words you want to use, but then it's going to let you formalize that language as you start getting your, their kids get their ideas understood.
So you want them to understand it turned, okay, let's be more descriptive. What do you mean it turned how, right? And then as you see, you can see what other students are doing in there. And so the kids start actually talking to each other. It's sort of like when we have students repeat things and the language gets a little clearer as you go along in classroom conversations, right? They take on the terms that their friends have been using. That also happens in these, depending on how long you time those out. One of the things I like about Desmos is you can time things out. You can say, give them this much time here. You can pause it if everybody seems to be having trouble with the same screen. You can pause and pull everybody together and have a quick conversation and then send them back to work on it and do, some pretty awesome, nifty things. But it gives you options and you get to see, in real time what the students are doing with the activity. But this is a great introduction to all those different translations that happen. One of the things I can do is take a picture of something. If I wanted to snapshot what Jennifer did, I can snapshot that and pull it into something else so we can have a different conversation about that. But looking at what Jennifer's did, right, in this one is pretty interesting, right? And so you can have a conversation with a whole class or a small group of kids about exactly what happened to this shape, what happened, right? So let's talk about this one. What happened in this shape?
As I typed, it got squished.
It got squished, right? And that's what students are gonna say, right? It got squished. And so we can talk about, okay, so in what ways did it get squished? Right? Did it get squished all around? Right? So it got squished, but then also spread out, as Cindy said, horizontally, right? And so we start talking about different actual math words for these things as we go. And depending on the shape that you chose, right, you had all sorts of interesting things. The more complicated your shape, right, the more complicated your talk was. This one, right, for instance, also squished, but it's a little clearer because the shape is a little more simple, right? And so your kids that had lots of fun with playing with that, making it really intricate, may have found it was interesting for them to figure out those things. But all the rotations and the different things are happening the same, regardless of the shape. The difference is the shape that they created. And I just love this one because it introduces that in a nice, friendly way. It keeps going and does some other really, really neat stuff. There's a screen where this thing happened, and I didn't let any of you get there, but it asks the students to describe. And historically what has happened as you go through and do more of this work, their language about what happens gets a little more precise and a little bit more about what you would expect. They start talking about the direction that it went in and that it spun, even if they're not using the actual correct mathematical language at the point. This is meant to be done early on in that work. Another nice feature about Desmos is it's got some teacher moves. And so if you're new to using this technology, it gives you some things to think about as you're going through the different screens in the pre-mates, which is really helpful. Okay, any questions? Okay, so we'll go back to the presentation. So the standards here, there are two that this one starts to lean into, and it is sort of experimenting, right? Verify experimentally the properties of rotations, reflections, and translations. And you just start to look at what happens. Students need experiences at what happens when shapes move in certain ways. And so that experience it has to happen. Like, it's not that we're memorizing that lines are congruent to lines and all those sorts of things. They need to intuitively see it and feel it. And then understand that it's congruent if I do a sequence of things and I don't do this, the technical term of squishing, right? If I'm not dilating it or anything, if it's just rotating and reflecting and translations, it can still be a congruent figure. Okay, so those are the standards that go with that. I'm gonna lean into a different area, and this is sort of an extension of one of the things that Kelly started yesterday, which is area becomes surface area. Go from 2D shapes to 3D shapes. And nets really are an amazing way to do this. You've got lots of options for nets. If you're starting with your good old rectangular prism, regular ordinary boxes that are coming to people's doorsteps these days, because we're having lots of things delivered, is a great place to start for that. But nets are pretty easy to get a hold of and to have students get a hold of. And so that is a thing we need to give kids more experience just doing and building, regardless of the grade that they are. If you're doing the volume for 5th grade and moving into 6th grade, you're making these and talking about them in terms of filling the volume of rectangular prisms, right? And so getting experience making nets goes a long way. But in 7th and 8th grade, we get more complicated with our nets. Okay. So one of the things that I wanted to show you today is this amazing NCTM resource dynamic paper. So in your packet, I gave you some really nifty nets and things that I made, but I wanted you to see you can make nets of all sorts of varieties. So I can make a cube one, I can make a dodecahedron. Let's make one just because that seems like a fun thing to do. Oh, it's too big. I'm gonna make it with one. So there's a dodecahedron, right? So you can make any number of different kinds of things. So you can make cylinders. That's really more what we're talking about for the standards we're working with. So I'm gonna erase that one. Yes, I want to delete all of those. And I want to make a cylinder. So I can make a cylinder. All sorts of different sizes up to what will fit on one regular sized sheet of paper. But the other things I wanted to show you that live here are you can make shapes and tessellations and number grids and all sorts of really amazing things that are useful for math. But graph paper is pretty fun, and you can make isometric dot paper, which is just the best thing ever. I gave you both centimeter and inch isometric dot paper in the packet for the handout for this session. But you can go in and build your own with different sized spacing based on what you want students to do with it. But that's really, really good for geometry work for students actually getting a sense of the space and being able to draw and do representations of things that they've built perhaps with blocks and cubes. And so it goes a really long way in helping them do those other sorts of things. And then for all my math friends, which is all of you all, you can do this. You can make pattern block sets. You can duplicate that and on one page you can fit 3 of these bad boys and make a nice set of pattern blocks. You can color them. So I can make them, oops, get out of there first. I can make them the color of a standard set if that's what I want to do. And it's just pretty awesome. If you need kids to be able to have access to this, or you need access to this and you don't have these, you can make a lot of the things that you need. And I just love it. And CTM is super good for that. Okay. Any questions about the dynamic paper? It is pretty awesome. It works really well from a regular computer, laptop, and tablet. And it is pretty darn awesome. Yeah, Kelly just put the link in your in the chat box, and then in the slides, when you see this in the slides, it clicks through and takes you right to it as well. So it lives live in there as well. So nets are a strategy for finding surface area and volume. It is spending time building it, seeing how it works, seeing how the shape fits together, thinking about it in terms of what a 3D shape looks like spread out as a 2D object. Students need experiences doing that because it's going to help them with this whole idea of informal induction, because I'm missing a slide. Oh, there it is. Because these are the formulas for surface area and volume that go 7th, 8th, and a little bit into high school, but almost all of this is fair game for 7th and 8th grade. And I'm serious, nobody's got time to memorize those formulas. This is not how geometry works. It's not plug and chug. It is giving students experiences with the figures so that they build the connections, right? That when they're talking about in that formula that B stands for something, B stands for base. And when they've spent time building, right, the figures, they get an idea of, oh, this is what you mean by the base. I held that in my hand. I see what that meant. I see how those pieces put together. I get why the area of the base is the length times the width, because it's like my square that I've been doing for 100 years, right? And so students need to see how those shapes, basically get put together to become 3D figures, and then they'll see where some of the pieces, they make connections in the actual figures, right? They can actually label the measurements on the figures they've made and make those connections to the formulas, because the point is not to memorize the formulas. The point is to internalize what surface area and volume mean and finding the most efficient way to find it. For lots of kids, it's not plugging it into a formula. It's understanding that once I unfold something, I see that this is a big rectangle, and then I've just got to find the area of the two circles for a cylinder, right? And seeing that helps make those formulas make sense, right? So that when they see a formula, they know what it means, but they don't have to memorize it as a series of letters. It is intuitive, which is the point. And that's what that standard is for. And you'll see there's lots of connection between 6th and 7th and 8th grade algebra. It really is this connected strand that we need to spend lots more time on. So that brings me back to the Van Howell geometric thinking. The whole point of this whole strand, and I literally touched on 4.5 of the standards of 7th and 8th grade, but they're interconnected, and that really is a great big thing of the point. We have to make the connections between the relationships, between the properties. Students actually need to see and feel that, oh, that's why this is the way it is, right? That I can't have a specific kind of figure because it won't work, because I need to have, a certain kind of angle, and this shape won't have that kind of angle. And so making those connections is the whole point of middle school, particularly 7th and 8th grade geometry. If we don't give kids these experiences of visualizing it, analyzing it, and being able to do deduction informally, we're not actually going to get them to the deduction stage, which means all the geometry of high school and beyond isn't really accessible to them, right? They have to be able to reason through that so they can actually do the deductive work to talk about the relationships among the properties and then beyond.
Dee, this is the part that I'm really worried about for our students with regards to NTI, because
Yes.
it tends to be about this time of year, building on their number sense and things. And so I worry about these experiences that our students didn't get, the touching the cereal boxes, the cutting them apart, measuring with, and so there's some rich experiences that I think that this NTI time has some gaps in learning. So we'll have to be cognizant of that.
It is, and it is my worry going forward that some of the things that we think we can shortcut because, well, there's a formula for that we won't spend as much time on that we need to because we can shortcut it, because I'm really not sure we can shortcut it. So.
I'm with you. You cannot shortcut this. This is,
No.
This is for deep understanding, meaningful work.
Yes. Amy wrote in the chat box, we can't remove the thinking from math. And I think that is really important to say again out loud. We can't remove student thinking from math. That is the point. We're asking them to think mathematically. And we can't. Yeah, we really can't. But I know that those of you that are showing up for our 2 o'clock sessions actually are invested in this work. So you all can help us spread that message. Tomorrow, we actually do go on to high school, and Leah's going to work with high school geometry and some specific technology tools. And I'm really excited because I learn new things every time in those high school sessions, because it's been a while since I've done that high school work. And so it's great to learn those new things. So we welcome you back for that tomorrow. And please make sure you're following all of us at both Facebook and Twitter. And all of the sessions live on the website there. You can go back and look at anything that you may have missed or relook at things you want to pay attention to in some more detail. And please reach out if you have questions or need anything or copies of anything or just have a general question. Thank you all very much.
We appreciate your hard work on that. Really gives something to think about with regards to, I loved that dynamic paper. I love that. So that was super fun.
I spent a long time building lots of things on that the last couple of days. It was fun.
Yeah, it helps you to think through it. So we're so glad that you joined us in the afternoon. This is the time that we give Dee a shout out. Indeed, Kim Jones says, hey, that reminds me of all the possibilities and thinking about that dynamic paper for students. We'd love for you to unmute, and so to give Dee some comments about parts of the presentation today that you were especially profound for you, or things that you're really thinking about as presented by Dee.
I really like, this is Jennifer from Austin, Texas. I really like how you all have, I'm really elementary is my wheelhouse, but I feel like you're connecting what you've been doing to moving up the chain, so to speak. And that's really been helpful to me. And I feel like it helps me to grow and it sees where kids are going. And yeah, and I just feel like I'm going to spend probably the rest of the day on dynamic paper. So. I mean, you gave a lot more good stuff, but that's like, I'm like for my wheelhouse, like, oh, and I can do number lines that I struggle with all the time. And you can do multiple types of pictures. I've already noticed. So thank you. But y'all, I can tell y'all are putting a lot of thought and effort into what you do. So thank you very much.
Jennifer, you've been a vibrant addition to our afternoon sessions. And so we are so glad that you join us, because our goal really is to take you from where you are and stick with us, because we need, good mathematicians see the whole spectrum so that you know that what you're doing in your grade level and then how it affects the upper grade levels. So that's great.
Yeah, I'm a little scared of high school tomorrow, but I'll be here.
That's right. You go. She's Leah's a good one. She talks easy and nice. She's got this great vibe about her. And so you'll love hanging with us.
Yeah, my goal is that we see the coherence all the way through. So I'm glad that you noticed that. So that's good. Thank you.
That'll be fantastic. Well, from the Kentucky Center for Mathematics, we appreciate that you join us in the afternoon. Tomorrow, we will have our last installment of our Focus on Geometry. Next week has to be in more thinking about multiplicative reasoning. And so we'll see you tomorrow. Bye, everybody.
Thanks, everyone.